Hi, in this video I will be explaining about retrieval-augmented generation RAG. It is the technique of combining retrieval and generation for better AI. In this video we will be covering these topics. What is RAG? Why is RAG important? How does RAG work? Components of RAG, applications of RAG, advantages and limitations, and then a simple demo. So first of all, what is RAG? RAG is a hybrid AI model that combines retrieval-based methods, fetching relevant information from a knowledge source, with generative methods, that is creating new text. So basically there are two things. One is traditional retrieval things like searching a text from a database or from PDF file like that, right? So we'll be having some knowledge base. From there we can do the search to get record information. Okay, that is fetching relevant information from knowledge source, that is retrieval. Another one is generation. Generation, it's a very important thing these days. Like you might have heard about the word generative AI, right? So these chatbots like ChatGPT and Gemini, they have the ability to generate new content. They will be able to create new articles, new blog posts, and even they can create new images. In that case, it will be called as multimodal. Okay, internally it is using large language model like GPT-4. In case of ChatGPT, it is using GPT-4 model. These LLMs are powerful in generation things, but they have some limitations. In case of RAG, it is combining power of both retrieval and generation. That is the key idea of RAG, combining the power of both retrieval and generation. The key idea is it enhances language models by grounding their responses in external knowledge. Okay, so it's something like guiding LLMs with the help of external knowledge. Okay, so why is RAG important? The traditional models, AI models, are having few shortcomings. One is limited knowledge cutoff. Another one is hallucinations. Limited knowledge cutoff in the sense, actually, as I said, the ChatGPT is internally using GPT-4 model, right? That GPT-4 model is a pre-trained model. That means it was trained with a lot of data. So in case of these LLMs, they are trained with huge amounts of data. So with the help of a lot of computing power, they got trained. In that case, there should be some cutoff date. Say for example, they trained it 2 months back, then it will be having data up to that time period only. Okay, so it won't be having the latest information. Okay, so that is one key problem with LLMs. And another one is hallucinations. Hallucinations are like inherent nature of LLMs. They used to generate incorrect or nonsensical information. If you are frequently using ChatGPT, you should be knowing about that. Sometimes it used to give very irrelevant answer for simple questions also. So it is because of hallucinations. Okay, and other than that, lot of things are there because of wrong information with the training data. It can hallucinate. Okay, so there are two problems. One is limited knowledge cutoff. That means there is no latest information, and then hallucinations. Okay, so both things are important because for using any kind of LLM, it is important to have latest information, right? And similarly, if that information is not reliable, then the entire system will be facing problem, right? The problems are very important. So we have to find better solution, right? So that is where RAG is playing important role. So RAG helps to access up-to-date information, and it is trying to avoid hallucinations. Okay, how does RAG work? The step-by-step process is input query. So user first asks a question, right? And then retrieval. The model retrieves relevant documents from a knowledge source. And then generation. The model generates response based on the retrieval information. So for the user input query, first the retrieval system will retrieve relevant documents from a knowledge source or external knowledge. Then once after getting the context information, it will be sending that context information along with the input query to the LLMs for getting the output. Okay, so here it is the overall workflow of RAG. First, there are two things. Okay, one is like a one-time task. Another one is regular usage. One-time task is like we have to load the documents, right? So suppose assume that you are running an organization within your department. You may be having like assume that you have 5 departments. Okay, each department is having its own policies and some details about the departments, right? Suppose someone is asking some questions about your company. He cannot straight away ask the LLM. LLM won't be having that data, right? You will be having that data, but we cannot send all the data to the LLMs. Okay, suppose in this example, if each department is having one PDF file, we cannot send 5 PDF files along with the user query to the LLM. Okay, because of that context window limitation. So each LLM is having certain context limit. We cannot send a huge amount of data. Okay, that is a limitation. So in that case, we have to send only the relevant document along with the user query. So for that purpose, first of all, we have to keep all the documents in a vector database. Okay, there are different approaches. I'm just talking about the common approach. Okay, so first of all, we have to store the documents in a vector database. Vector database, it is like the search will be happening very faster, because of the reason is it will be keeping the data in a numerical format. Okay, so it will convert the text content into, or image content into, equivalent number. Okay, it will be storing only the numbers and along with corresponding associated text, but the search will be happening based on the numbers. So basically it will be very quick. Okay, and it will be effective in the sense I will explain. Okay, so first of all, it is very fast. Okay, so for that we have to convert the documents into embeddings. As I said, it's a numerical representation of that content. For that we have to use some LLM for embedding. For that that LLM will be different. They will be providing embedding services. We have to use that embedding services and then convert the documents into equivalent embeddings and store it in a vector database. There are various vector databases like ChromaDB, Facebook's Files, and Pinecone managed vector database. And in case of ChromaDB, we can locally use it. It's open source. There are various vector databases are there. We have to store the data in a vector database. Okay, it is one-time process. One time before start using our system, we have to preliminarily, as a preliminary step, we have to set up this. Okay, as I said, that vector database, that search will be faster, and another advantage is it's a semantic search. Okay, so not only keyword-based search, it will support semantic search also. That effectiveness of that semantic search will be depending on what kind of LLM we are using for creating the embeddings. Okay, that is a completely different topic. Like in the case of RAG, the overall structure is very simple. LLM is having some shortcomings. We are going to solve that problems with the help of external data. So for that we are using this RAG. So we are just augmenting the generative process with the retrieval step. That is the very key. That is a RAG. Okay, that is very simple. But in case of implementations and other things, like based on the requirements and usage, there are various things are there. Okay, but the scope of this video is for giving the basics. I'm just addressing the beginners in this video, so I'm just keeping it very simple. Okay, so the documents are converted into embeddings and stored in vector database. That is one time step. Okay, and then come to the actual daily process. Okay, so user ask a question. Okay, that question also, that query also converted into embedding. That is called as query embedding. Okay, query vector. So that query vector will be searched, will be used to search relevant this entry in the vector database. Okay, say for example, in our example we said 5 departments, right? So if you are asking, if a user is asking a question related to one particular department, say example he is asking about second department, and that query will be converted into that embeddings. That query embedding will be searched against this vector database doc embeddings, right? So it will be finding the data related to the second department, correct? So that is the nature of this vector search. Okay, here it will be fast as well as it will be doing semantic search. That is the key here. So once after getting the relevant information, now that is called as context chunks. That will be with the augmentation, it will be added along with the query and then sent to the LLM for getting the response. Now it will be something related response. Okay, the overall process is one-time process is storing the documents external data as embedding using LLM embedding. Okay, and the actual process is converting the user query into embedding, then do a vector search. There are various things, cosine similarity, that kind of approaches are there. Okay, so based on that, we have to find the relevant chunks, and we have to augment the prompt with that context chunks. Okay, like the prompt will be like we have to provide the query and the chunks, and then provide external additional information, like use the context information to give the answer for this query. Like that, we have to provide some system prompt also. Okay, so finally we will be getting the relevant response. That is the core concept of RAG. So if we are not using this RAG thing, then we may be getting irrelevant response. Okay, this process is grounding the LLM. That is one thing. And as I said previously, it will be useful for getting the latest information. The LLM may not be having the latest information, but the context chunk will be having that latest information. It will be using that information. So the components of RAG are retriever, generator, knowledge source. Okay, so the retriever searches large knowledge base for relevant information. There are various retrievers are there. Generator, it is like GPT models. It's a normal LLM. And a knowledge source. Okay, so for retriever to get the data, we have to have the data, right? So for that data, in case of our example, like a vector database, we have to store the details, right? So for that, we have to use some knowledge source. It can be, as I said previously, it can be any document, simple cases, or it can be like any crawler crawling latest information from various web sources. Okay, or any kind of database also. Applications of RAG. So a lot of applications are there. Okay, one is obvious. One is question answering for getting accurate answers to the user queries, and chatbots for more informed and context-aware conversations, because we will be able to send the context information, right? So that it can work properly based on the context information. And content creation, generating articles, summaries, or reports. We have to provide external data so that the LLM will be able to create the content with more information. Okay, so customer support, obviously, whenever the user asks any questions, okay, the customer asks the questions, that system will be able to give proper reply with the help of this external knowledge. For example, if a hospital is running a customer support system, the user will be able to ask any questions to this system in natural language, and that RAG system will be able to search the content, get the relevant content from the knowledge source, and then reply to the answer. So basically, I can say in two ways. Like one is like the retrieval system previously. In this case of this hospital customer support system, previously, if someone is asking a question, the representative in the hospital has to go through some PDF files or database. He has to do the keyword search and then give the answer, right? So that is traditional way. Okay. In that case, he will be able to get the answer only when the keywords are matching. Okay, that is the limitation. He cannot use the natural language. He cannot use like everyday simple languages. He has to use the keywords properly. In case of LLM, we can use natural language, but the problem is it won't be having the data, right? To get benefits of both things, we can. That is the name RAG. We are augmenting the generative process with the help of the retrieval of that content. Okay, so augmenting the generation using retrieval-augmented generation. Okay, so advantages and limitations. Advantages are obviously we can get the latest information, real-time or updated information, reduces hallucinations. Okay, it combines the best of retrieval and generation. So it's obvious advantages of RAG. Limitations, so again it depends on the quality of the knowledge source. Even if you are able to use the external knowledge source, if the quality is not good, then again the problems will continue. So it depends on the quality of the knowledge source. And computationally expensive, converting the documents into vector database, that will take significant computing power. And if you are using API, then the API usage will be somewhat costly, not up to the level of generative that cost, but still we have to pay for that. Okay, so computationally expensive. And compared to other approaches, few shot learning, other things that recommend for data set for training is comparatively high. Here we have to have significant amount of data in the external So let me show a simple demo. Okay, so normally there are two approaches. Okay, one is using the open source free models. Okay, we have a lot of things. Okay, you can search in the Hugging Face or Kaggle. We can get a lot of embedding models. Okay, but based on my experience, if we use the embedding models provided by large organizations like OpenAI, then it will be, the performance will be good, and the other, basically it will be better. Okay, but we have to pay for them. Okay, that is one thing. So in this example, I will be showing simple example using Hugging Face. Okay, but in actual usage, mainly I used OpenAI API. Okay, so here the coding. First of all, we are importing the record libraries. So this code we use LangChain. LangChain is a framework or library for AI developments. Okay, it will be easy to handle various models and various kinds of vector databases like that. The coding will be simple. Okay, but the maintenance, based on my experience, the maintenance is continuously they are continuously changing their libraries and things. Okay, but the obvious reason is the AI is developing very fast, right? So they, to catch that, they're continuously updating their libraries also. Okay, and moreover, if you use the coding individually, then understanding the concept will be easy. But in case of LangChain, you suppose if you are developing for if you want to save a lot of time, then you can go with LangChain. But for learning purpose, I would recommend doing everything separately. Okay, without using any kind of framework or libraries. Okay. But for as a beginner, for giving some overview, I am using LangChain here. Okay, so that you can understand the full flow easily without getting deviated by each and every individual coding. Okay, so here the overall, we are first importing all the record libraries. Okay, so the steps are, first we have to, as I explained in the diagram, there are two things. One is one-time step, and another thing is that actual flow, like retrieval and augmenting the prompts, and then generation, right? So that three steps. So totally one step is, first step is one-time step, then three steps for every query, right? So the first thing is we are preparing the documents. So here it's a very simple, so just for explanation. Otherwise, assume that each document is like 2-3 pages lengthy. Okay, so here vitamin C helps boost immunity, exercise improves mental and physical health, drinking enough water keeps you hydrated and improve focus. Okay, it's a document. And chunking is important concept in RAG. Okay, so we have to chunk means splitting the document into different sections so that it can fit into the context window of the LLM. Okay, so for that we have to provide overlap also. So I don't want to give all the details here, so that we can fully focus on the overview. So basically we prepare the documents and chunking that. Okay, and then embedding, creating the embeddings and storing it in the files. Okay, vector database. Okay, so for creating embedding, we have to use the embedding model, Hugging Face embedding we are using. So for using Hugging Face, we have to use the Hugging Face API. Okay, so I already loaded the, exported the Hugging Face API in the environment. So suppose if you are going to use this code in your environment, make sure that you loaded Hugging Face. Okay, so you have to get that details from access tokens from here, Hugging Face, and then you have to load it in the environment. Then you can use this code. Okay, so first we are preparing the documents, chunking it, splitting it, and then converting the each chunk into embedding, and then storing the embeddings in the vector database. Okay, this is one step, for the one-time setup. Okay, and then actual charting, for that we are using this LLM. Okay, and we are augmenting the query by giving this prompt, preparing this prompt. Okay, so using this prompt template, we are using we are asking the LLM to use this context for answering this question. Okay, and it has to give answer in this format. Okay, this is the context, this is the question, you have to give the answer like this, like that we are asking. Okay, it is very important, because otherwise it will be giving answer in a different format. For preparing the example, I didn't give it this this format first time, so it behaved differently. So for giving the example simply, I arrived with this template. Okay, so now we are creating the RAG chain, and here this is a query, user query. How does exercise affect health? Okay, so once after running the this chain, it should give the answer. We are printing the answer. Okay, so here three things are there, right? So let us see what is happening. So I'm running this script. After running this, it gave the answer, right? Exercise improves both mental and physical health. Okay, for that question, it provided the proper answer. And apart from answer, it provided explanation also.